Imagine you are building a skyscraper. Um, but instead of drawing up meticulous blueprints or pouring concrete, you just walk onto an empty dirt lot. You just whisper this really vague description of a building to a massive fleet of autonomous construction cranes, and then you just walk away. I mean, that sounds like a recipe for a catastrophic collapse, right? You wouldn't let anyone step foot inside a building constructed that way. But in the software development world right now, we are essentially letting the cranes build the skyscraper completely blind. It's this exploding phenomenon known as vibe coding, where you use natural language prompts to let AI write your software for you. It seemingly allows the user to just forget that the underlying code even exists. You just, give in to the vibes, which is terrifying when you actually think about it. And to understand the gravity of this shift, I have pulled together some fascinating research. We are looking at a massive empirical study analyzing over 300K AI generated code commits, some academic papers on software architecture and computer science education. And then we will discuss how do we actually use these powerful AI tools without shooting ourselves in the foot. Because the goal is not to use an AI, but how to use it effectively. We will also discuss a core philosophy called AI native developers. Okay, let's unpack this. So we are moving at light speed with these AI tools. Anyone can seemingly generate a working app in seconds. But what happens when almost no one is actually reading the code that runs our entire digital infrastructure? Yeah, that tension is driving a massive wedge through the tech industry nowadays. The allure of vibe coding is, well, it's intoxicating. I mean, it offers unparalleled speed and accessibility for anyone. But the fundamental flaw here is that AI doesn't actually understand the software it's building. It's merely predicting it. Let's look at exactly what that prediction looks like on the ground level, because there's a story from a senior developer with over 14 years of professional experience. He's been coding since he was 12, highly competent guy, and notably, he's actually a big fan of AI. He uses Claude Code daily. So he's not just some anti-AI hater, but he shared this specific incident that absolutely terrified him. He was working on a feature for a CSV file import, and he just asked the AI to fix a failing unit test, which for an AI coding assistant should be a relatively mundane, routine task, right? But when he reviewed what the AI actually wrote, he found this massive immediate red flag. The AI had quietly inserted a single line of code that modified a variable called user ID. And in the context of this specific application, that variable determined which user was going to be billed for an action. That is a disaster waiting to happen. By adding that one line, the AI essentially created a silent loophole where user A could upload data and charge it directly to user B's credit card. I mean, why on earth would an AI invent a billing vulnerability just to fix a basic file import test? Well, what's fascinating here is it comes down to what data scientists call statistical priors. So, what does that mean? It's just a technical term for the AI's built-in biases based on what it has seen most often in its training data. AI is a statistical prediction engine. It doesn't magically sniff your needs without you mentioning explicitly. It certainly doesn't understand your company's specific billing API. What it does know is that across the billions of lines of open source code it digested during training, CSV imports are frequently tied to administrative tools, and administrative tools frequently require user ID overrides. So it was just blindly trying to satisfy the failing test by guessing that this variable was missing based entirely on statistical probability. It just thought, hey, this usually goes here. So essentially, vibe coding is like handing the keys to your business to a junior developer who types at 1,000 words per minute, is incredibly eager to please, but has absolutely zero common sense. And to make it worse, this eager junior developer writes code that looks completely professional. It looks perfect on the surface. Syntactically, it is flawless. It functions. And because of that, debugging AI generated code often takes a human developer longer than if they'd just written the feature from scratch. Because you aren't looking for a misspelled word or a missing semicolon. You are hunting for subtle, logical hallucinations buried in thousands of lines of code, which is wild. If a senior developer with 14 years of experience almost missed a critical business destroying flaw on a single line of code, what happens when we zoom out to the entire open source ecosystem? The data on this is actually staggering. There is a major empirical study titled Debt Behind the AI Boom. This paper is crucial because it moves the conversation away from isolated developer anecdotes and into hard, measurable realities. They looked at a ton of data. The researchers analyzed over 300,000 verified AI authored commits across thousands of real world GitHub repositories. And they didn't just target one tool either. They looked at the output from GitHub, Copilot, Claude, Cursor, Gemini, and Devin. So they covered the entire landscape. And what they found is that more than 15% of the commits from every single one of those tools introduced at least one new issue into the code base. And the deeper breakdown of those issues is where the real concern lies. The researchers found that a massive 89.3% of these introduced flaws were what the industry calls code smells. Code smell isn't necessarily a bug that crashes the app immediately, okay? Think of a code smell as a structural weakness. It's a maintainability issue. For example, the study highlighted a really common AI practice, which is exception handling without exception string in Python. In plain English, this is when the code basically says, if any error happens whatsoever, just ignore it, hide the error message, and keep the application running. The AI does this because it prioritizes short-term speed. It wants to get the app to compile right now over long-term stability. So, when the app inevitably crashes 3 months later, the system has hidden all the error logs, making it an absolute nightmare for human developers to figure out what went wrong. Code smells are essentially the high interest rate you pay on technical debt. The AI is taking out a predatory loan on your software just to finish the job 5 minutes faster. And to be fair to the AI, the study did note that these tools actually fix slightly more code smells than they introduce. Like they are great at cleaning up messy formatting. But the study also found that AI introduces more correctness and security issues than it fixes. We're talking about real actionable vulnerabilities like command injection risks, where a malicious user could hijack a server. Here's where it gets really interesting. The researchers tracked the life cycle of these AI-introduced issues to see if human developers were catching them during review. And they aren't. 22.7% of these AI-introduced issues survive at the latest repository revision, meaning nearly a quarter of these flaws are just sitting there, permanently baked into live production code. If AI is actively introducing more security vulnerabilities than it resolves, and a quarter of them are just slipping past human reviewers permanently, aren't we just building a massive, invisible, ticking time bomb of technical debt? We are suffering from automation bias because it looks so clean. When a machine hands us a perfectly formatted block of code in 2 seconds, our brains naturally overtrust it. We assume the machine did the thinking. Consequently, we are accumulating technical debt at a scale and velocity that human engineering teams have literally never dealt with before. And this problem goes far beyond a few buggy lines of code or a rogue variable. The AI isn't just writing the bricks, it is secretly redrawing the blueprints entirely. There's an academic paper titled Architecture Without Architects that coins a term I find deeply unsettling, which is vibe architecting. Historically, software architecture is an incredibly deliberate, heavily scrutinized process. Human architects spend weeks deciding which database will talk to each other, how microservices will talk to each other, how to structure the core logic. But with AI agents, those monumental system level decisions are happening implicitly in seconds. It entirely bypasses standard human review processes or documentation. The paper identifies 5 specific mechanisms where AI makes these silent choices, including how it breaks down tasks and defines integration protocols. But there's this one concept which is very interesting. They call it prompt architecture coupling, meaning the specific casual words you use in your prompt directly dictate the massive infrastructure the AI decides to deploy. The researchers proved this with a brilliant case study. They asked an AI agent to build a basic customer service chatbot. In their first test, the prompt was straightforward. Answer product questions from a FAQ. It did fine. It behaved perfectly. It built a simple flat application consisting of 2 files and exactly 141 lines of code. But then they tweaked the prompt slightly. They added a declaration of capabilities. They told the AI, "You are an agent with tool access. You can search a knowledge base, get an account, or escalate to a human." Just a few extra words, okay? Just by adding the phrase tool access, the AI completely lost its mind. It exploded the codebase from 141 lines to 827 lines across 6 files. It silently added a tool registry, an agent routing loop, and a full SQL database just to manage the state of the application. And it is critical to understand the mechanism behind why it did that. Here, the concept of statistical priors we just discussed comes again. When the large language model sees the words tool access, it statistically associates that exact phrase with heavy, complex agent frameworks like LangChain, which appear millions of times in its training data alongside those specific words. So it assumes statistically that if you want tool access, you must also want the massive routing loops and databases that usually accompany it. So it drags all that heavy infrastructure along with it without once stopping to ask the developer if they actually need a database. It's like asking a contractor to build a simple wooden shed in your backyard. But because you casually mentioned you might want to keep a few drinks cold out there, they secretly excavate your entire yard to install a commercial walk-in freezer without asking you. And imagine the contractor didn't even put the freezer on the blueprints. So, 3 years later, when you try to plant a tree, you hit a massive pipe you didn't know existed. That is what architectural bloat does to a code base. In a normal environment, adding a new database requires engineering meetings, security reviews, extensive documentation. Through vibe architecting, the AI makes that choice in 3 seconds, and there is zero record of why the decision was made. So, if the AI is secretly redesigning our entire system architecture based on a two-word whim, how much control do developers actually have inside the software they're using every single day? So, if you're watching this and thinking, well, I just won't use AI to code, problem solved. The data says you're already going to be left behind by developers who are moving 10 times faster than you. So, how do we actually use these powerful tools without shooting ourselves in the foot? For that, we turn to a philosophy called AI native developers. The core mantra of this entire approach is delegate the doing. Own the thinking, delegate the doing. That draws a definitive line in the sand between a vibe coder and an AI native developer. A vibe coder lets the AI do both the thinking and the doing, which results in those fast, bloated, broken applications we just talked about. The AI native developer treats the AI purely as a high-speed execution engine. To enforce this, the manifesto introduces a highly structured workflow called the feature loop. Instead of just throwing a massive, vague prompt at the AI and praying for a good result, you iterate through 5 strict steps: think, prompt, test, code review, commit. It's that code review step that really separates the pros from the amateurs. The manifesto highlights 4 essential questions you must force the AI to answer before you ever accept its code. First, explain this in plain English. Force AI to prove it understands the logic it just regurgitated. Second, does this cover various edge cases? Third, can AI break this massive function down into small or readable steps? And the crucial fourth question, can AI write a test for this? By forcing the AI to explain, isolate, and test its own output, you are actively neutralizing the automation bias we discussed earlier. You are managing the risk. It brings us to yes man issue of AI. AI is fantastic at saying yes, right? It will say yes to building any bloated feature you ask for. But it is fundamentally incapable of saying no. It won't stop and tell you that its architectural choice is going to cost your company thousands of dollars a month in AWS server fees, or that the database choice it made completely destroys the scalability of the application. The human developer must be the one who knows the code architecture well enough to say no. So the question is, if human developers are basically transitioning into full-time reviewers and system architects, what does this mean for a college freshman today? Think about a computer science student who might never actually have to write a program from scratch. How do you even teach software engineering in this reality? It is the most hotly debated topic in academia nowadays. There are 2 excellent write-ups on this that I came across: a thought-provoking post from CodeVA and a comprehensive academic paper on CS education in the age of generative AI. And they both take a pretty strong stance. Both sources argue forcefully that AI isn't making computer science obsolete. Instead, it is violently shifting the focus away from traditional programming, which is essentially just memorizing syntax, and moving it towards true computational thinking. Computational thinking is a key word here, meaning the human focus is entirely on problem solving, finding algorithmic bias, evaluating outputs, and designing complex systems. The researchers point out that computer science education is moving away from recall. You used to sit in a quiet exam room and write C++ code on a piece of paper from memory. It was brutal, right? Now, education is shifting entirely to recognition. Can you look at 800 lines of AI generated architecture, critically analyze it, spot the security flaws, and iterate on it? So, what does this all mean? The researchers in the paper use a baking analogy to explain this shift. They say learning to code with AI is like making a meringue. You don't need to know the biological process of how a chicken makes an egg to whisk up a meringue. You just need to be able to recognize the correct glossy texture when you see it. Well, it's a good way to look at it. But I have to push back on this. If you don't know where the egg came from, how do you know the AI didn't just hand you a plastic egg? If we completely stop teaching the fundamental syntax and the raw mechanics of coding, aren't we losing our intrinsic ability to spot the fakes? Like, if a student has never built a database from scratch, how do they recognize that the AI just implicitly added a terrible one to their project? By the way, the experts in the paper actually acknowledge that we are walking a tightrope here. The people who truly understand how AI works, who understand its statistical limitations, and who own the foundational knowledge to critically evaluate its outputs, they will be the architects shaping the future. But those who blindly accept vibe coded outputs, who just take whatever the AI hands them because it's fast and easy, will simply inherit a world of decisions made by machines. That is a chilling but really necessary perspective. To sum this all up, vibe coding, as in just whispering to the autonomous construction cranes and walking away, offers incredible, intoxicating speed. But that speed comes with a massive hidden tax. You're risking silent security vulnerabilities, 1,000 lines of architectural bloat triggered by a single phrase, and unresolved technical debt that accumulates like a ticking time bomb. It's a steep price to pay. The key to surviving and thriving in this new era isn't to reject the tools. It is to evolve into an AI native developer. You have to own the thinking, exercise rigorous architectural judgment, and operate with a strict trust, but verify workflow. It ultimately comes down to recognizing that the AI is an incredibly powerful assistant, but it is not and cannot be the architect. And I want to leave you with this final thought to chew on. If you are looking forward to the day as a developer that AI takes over security entirely so that you don't have to work on Christmas Day, fixing a zero-day exploit, where you have literally 0 days to fix it before attackers destroy your system. But if we completely transition our education system to recognition rather than recall, that is, analyzing the AI generated code rather than writing it, do we lose the muscle memory required to manually patch that 0-day vulnerability when the AI inevitably hallucinates and breaks down? If we let the autonomous cranes build the entire skyscraper, while we just whisper from the sidelines, will anyone remember how to actually swing a hammer when the roof caves in? A monumental question for the future of how we build our world. Thank you so much for watching the video. Keep questioning, keep verifying, and I will catch you next time.